So, a practical application for working with these types of reactions is something called selective precipitation. So, we can use it as a purification method to separate two cations that are in solution. And we do this by adding an anion. So, the anion will precipitate with only one of the cations, and then we can filtrate the precipitate that forms, and the other cation will remain in the filtrate. This is something that you will be doing. This is like a very important purification method that you'll be doing in experiment number 10, qualitative analysis, which is not this week, but the following week. So an example of this is phosphate ions. So phosphate ions are present in water that is discharged from manufacturing facilities. And we want to get rid of these ions because they're really harmful to marine life as well as humans. So we can add lime or calcium hydroxide because this will then precipitate into hydroxyl apatite. And so we can use filtration to precipitate out the hydroxyl apatite. So this is an example of how knowing molar solubility of certain ions, how we can use these types of reactions to use it as a purification method, right? To actually isolate certain ions that we may want for something, or to isolate ions that are harmful and use it as sort of a purification method, as seen here. So let's look at another example. Consider a solution of magnesium and barium ions. They are at the same concentration, and carbonate ions are added slowly. So here we have a solution with two different cations, magnesium and barium, and we're going to add the anion carbonate. What will happen? So to predict what will happen, right, we can look at the solubility product constant for both barium carbonate and magnesium carbonate to compare their solubilities, So because there is a difference, right, because the magnesium and barium ions are at the same concentration and there is a difference in their solubility product constant, we can use the carbonate ions to separate magnesium and barium ions. So think about this. Based on the KSP for both, which will precipitate first? Which will precipitate first? So it turns out the barium carbonate will, because it has a lower solubility constant. So that means that it is less soluble. It is less soluble than magnesium carbonate. So it will precipitate out first.